So welcome back, ladies and gentlemen. This is part 2 of our lesson for Friday, February 23rd. We're going to look at function notation. This is found on the second page of your handout. It's really related to example 3, 4, and 5. I'm actually going to skip example 3, and I'm going to talk really introduction about what function notation is. And again, notice how I introduced this ordered pair. I talked about x being the independent variable, y the dependent. It's also the input and output, and domain and range. A lot of you actually understand that, but domain and range. This one actually makes more sense for input and output. So first of all, I need to teach you what this looks like. I know it looks like f times x. So that's what it looks like, f bracket x bracket. That's not how you say this. The way that you say this to someone is f at x or f of x. So most students look at this and it looks like fat x. That's easy if some kids remember, but that's f at x. Okay. But what does it mean? What does it mean? Let me show you with this ordered pair. In grade 9 and 10, we use ordered pair like this, x comma y. In grade 11, some students find it a little easier than I write like that. So a lot of you are slowly understanding that f at x is really the y coordinate. Here's a specific example from grade 9. In grade 9, if we ask you this question, given y equals 2x plus 1, solve for y when x is negative 3. Now notice I wrote that out in English. A lot of you actually understand what I'm going to do. We need to do this question, y equals 2x plus 1, and solving for y when x is negative 3. A lot of you understand, well, 2 times negative 3 plus 1, you would solve this. You would substitute and replace. So y is equal to negative 6 plus 1, y is equal to negative 5. That's in grade 9. Everyone see that? Pretty easy, right? In grade 11, this is what the question would look like. F of x equals 2x plus 1. So notice it looks exactly the same like the equation. So what's the question, Mr. Chen? The question would be something written like this. Find, and again, how do you say this? Again, this is not f times negative 3. That's not what that says. Find f at negative 3. Let's pause for a second to absorb this. This negative 3 is like our x, which stands for input. Now I'm actually concerned about what the rule is. And in this example, the rule, or the production, or the organization that we're going to use is this equation, this linear relationship. So a lot of students realize that this f at negative 3 basically translates what we're going to do mathematically, what we've been taught in grade 9 and grade 10. So what are you going to do? Replace all the x's with negative 3. And notice it's now the same, or virtually the same as that question. So that's all it is, ladies and gentlemen. Conceptually, some students find this hard. Let's jump to example 5. Unless there's a question, sorry. Is there a question from the class? Any question at all? So f at x is going to be on your test on Monday. And again, for those people watching at home, it's also going to be on Friday. Not so many questions, maybe only 2 questions, but you need to practice this. So in example 5, I just decided to copy 3 of the examples. And again, feel free to ask me questions when I see you online on this Wednesday and Thursday in the afternoon. We have 2 functions. The way that you say this first one, f at x is equal to 2x minus 7. Notice this is g at x equals x squared plus x. A question that a lot of students ask, Mr. Chen, for question A, do I do it for both of these? The answer is no. Notice it says f at c. So I think a lot of you know, we're not going to use this one. We're going to use this one. And what's the input? Some of you are a little queasy or weirded out. Again, you're so used to inputting numbers or fractions, and a lot of you realize now we can actually input expressions or other variables. In this case, this is a variable. I don't know what this is. Who cares? It's like, I'm going to put chocolate into this expression. Okay, let's do it. So the answer for this is 2 times c. Before we continue, any question? notice what we're doing? We're just gonna input whatever this is, and it's the letter C. But now let's keep on going. 2 times C is 2C minus 7. Mr. Chen, is that the answer? Yes, that is the answer in this case. I don't know what C is, but who cares? Who cares? Who cares? That's why this one tends to be a little bit easier. In example 3, you can try that at home, or maybe I've already done the video on it. I can't remember. I'm getting so old. I think a lot of you can do that, and we can definitely check that afterwards. Let's try question D though. How would you say this? This is f at x minus 2. So again, one more time, notice I decided to copy the question. We're not going to use the g at x equation because that's not what it says. This question says f at x equals 2x minus 7. So let's input 2, and it's x minus 2. Let's use a different color just to show it off. And that's what we're doing. Let's pause again for effect. Any questions from the class? Am I going too fast? I think a lot of you understand this. Any questions right now? A lot of you realize now maybe we should expand this. And that is why you've been taught some algebra. Now, in terms of understanding why we're doing this, there's a point. So just to share with you, eventually we'll get to the reason why we're doing this. Why are we doing this and what does it really mean? We're just not there yet, but if you really want to know, it relates to how transformations do occur. We're not there yet. We just have to get used to the algebra and that. Our last question that we're going to kind of do, unless there's a question from the class. Notice this question is a little bit tricky. This is f at 3 plus g at 2. And there's a couple ways of doing this question, but I would recommend for my students in grade 11, take this one a little bit easier. This is typically a test question or something similar to this, just to make sure you're okay. We separate them both. So some students realize if I break this down into the components, f at 3, watch what I'm going to do. 2 times 3. And what's the g at 2? G at 2 is this one. Although I'm writing them all simultaneously, I would recommend you just do one of them first and then you do the other. But I'm just trying to showcase this scenario. G at 2 is, of course, something squared. And we'll use the color. Hopefully this yellow will pop out. So that is 2 there, and 2 there. Hopefully I copied the question right. I think I did. Yep, just want to make sure. And notice the differences. Hopefully everyone's all right. Any question of what the inputs are? Again, I recommend you just do one and then you do the other. And it'll make sense in a moment. So what's 2 times 3? That's 6 minus 7. That's negative 1. Everyone agree? And how about this one? 2 squared, that's 4. Plus 2, that's 6. Some students say, Mr. Chen, what do I do now? The whole point, and this is like the idea of actually adding components to a item. So you have one function, then you have another function, and then you're combining it, right? It's like saying, hey, you can have a wedding, and you can have a carnival. Let's combine the two. A wedding carnival is incorrect. But I mean, it's possible. Anything can happen. Anyways, what's f at 3? F at 3 happens to be negative 1. What's g at 2? That's 6. For emphasis, notice, we are not subtracting them, we're adding these two together. Now that we know what they are, we can keep on going. And that, of course, is 5. I don't know what this answer means. I don't know what it really represents, but that's what we do when we combine these two functions. Any questions of the class? I know I only did 3 out of the, I think, 8 or 7 of the questions. Any questions at all?